Hello class, good afternoon and
Good
namaste.
afternoon, sir.
Yes, good afternoon. Welcome back. So feels so good to see you again after a long time. Okay, so class 9, how are you? So I hope you all are fine there. So are you ready to read? Are you ready for the lesson? Okay. Today we'll start from the same place, or the same part where we were last time. Previously we were talking about inertia of body, which we classified into three types: inertia of rest, inertia of motion, and inertia of direction. Okay, and we are supposed to read only two types of inertia. They are inertia of rest and inertia of motions. So with examples. Okay, before I begin today's class, okay, that's sharing a screen. Let me give one example. So if you can hear me, if we beat the blanket, or let's say carpet, okay, if we bleed the blanket or carpet with a stick, so you can easily see the dust particles separate away. Okay, so when we beat the carpet or blanket with a stick, so we can see the dust particles blow away, the dust particles separate away from the carpet or blanket. You know, the reason behind that is there is inertia, and that is inertia of rest. That is inertia of rest. So before we beat the blanket with the stick, both the blanket and dust particles are in the state of rest. Now when we start beating the blanket with a stick, by the force the blanket comes into motion, but dust particles still remain at rest, and due to which it makes dust particles separate away from the blanket. That is because of inertia of rest. So now it's time to start today's class. So let me begin with sharing the screen. Ranjila Miss, are you there? So may I get permission to share the screen, please? Ranjila Miss, त्यहाँ हुनुहुन्छ? हजुर त्यहाँ हुनुहुन्छ?
भयो होला सर हेर्नु त
Okay. हजुर हजुर हजुर. Okay. Now be ready, everybody. So here, okay, today we are going to discuss about inertia of motion. So last time we discussed about inertia of rest with examples. Then we'll try to connect with another topic, momentum, and slightly we'll talk about Newton's laws of motion. So first, inertia of motion. Okay, what is inertia? So we define inertia as the inability of a body due to which it cannot change its position itself. So in another word, so we can say that inertia is the property by which a body can stay or remain in its own position. If the body is at rest, the body can stay, remain at rest forever, unless the force is applied on that. So if the body is in motion, okay, continuously, the body can be in motions in straight line unless the force is applied on that. So the property by which a body can stay in its state or position is inertia. Okay. Now, second type of inertia, so we are going to discuss today is inertia of motion. So two states we have been discussing. One is rest, another motion. Either the body is at rest or in motion, and to change the body from rest to motions, okay, or motion to rest, we always need to apply external force, and which should be unbalanced. So only unbalanced force can change the position of a body. The body of at rest can be changed into motions by unbalanced force, or the body in motion can be brought into rest by applying unbalanced force. Now let's suppose when the body is in motion, that means body is continuously moving. So if you do not apply any force, okay, to stop that body, the body continuously moves, and that property, okay, is called inertia of motion. So simply, so we can define inertia of motion is the inability of a body in motion to change its state of motion by itself. So by its own, so no any object can or is able to change its position. So a body is able to change positions whenever we or any by any means the force is applied on that. Otherwise, moving body continuously keeps on moving. Okay, if we do not apply on force on that to stop it, to bring that into rest, that means the body cannot, okay, come to rest if that is in motion, and that inability is called inertia of motion. Okay, that is the property by which a body can always stay in motion if that is already in motion. This is the definition and meaning of inertia of motion. That means the body is already in motion. Okay, then only, okay, we can say, okay, the body is defined in the conditions of inertia of motion. Here, first example of inertia of motion. So if you look at the picture carefully, so you can see there when the red light is on, okay, on the road by the traffic light, suddenly a driver applies the brakes, so the bus comes to rest, and you can see the effect. Okay, when the brake is applied suddenly, all the passengers, who are sitting on the seat or let's say standing, they lean forward. This is because when the brake is applied, okay, the force applied by the brake that acts on the lower part of the body. Okay, so lower part of the body gets force by the lower part the, of the body of passengers can come to rest, but still, okay, the upper part of the body is in motion because the upper part of the body do not, okay, or does not get the, okay, force applied, and so why, due to that continuous state of upper part of the body in motion, okay, and we find the effect that the passengers lean forward, okay, when the driver applies the brakes or when the bus is stopped or when any vehicle is stopped suddenly, and this is inertia of motion. So before applying the brake, before bringing the bus into rest, okay, the bus, the driver, all the passengers inside the bus are in motion. But when suddenly brake is applied, that means force is applied, okay, to bring the bus into rest. The time the bus comes to rest, okay, even the lower part of the body of the passenger come to rest, but the upper part of the body, okay, they are still in motion, and this happens because of inertia motion. So sometimes, okay, even some passengers or some people get injured, they get hurt. So when the bus is stopped suddenly, that happens due to inertia of motions. So passengers jog forward, passengers lean forward, okay, in the moving bus. When the bus is stopped suddenly, is the example of inertia motion. So next example here, this is the fan, and the picture is trying to show the fan in, motions, in the state of motions. The fan is moving. So whenever we, okay, switch off, so whenever we cut off the electricity, when the power is off, even though we can find, okay, the fans or let's say the wings of fan continuously move for a while. So an electric fan continues to move for some time even after the electricity is switched off. Okay, this is also because of what? Inertia of motion. The fan moves, everybody knows, by the power, by the energy given by the electricity. So by the continuous supply of electricity, that means by the applied force, by the energy, the fan comes into motion. As the fan acquires the state of motion, it continuously moves. But when we switch off or when the switch is turned off, okay, to cut the supply of electricity, to cut the supply of power of electricity, the fan remains moving, isn't it? Because the wings of the fan, okay, at the moment do not directly get the effect of force. So why that the wings of fan continuously, okay, be in the state of motion. So even after the switches off, the fans move because of inertia of motion. So let's give more examples about inertia of motion. And I hope you are listening to me. Please concentrate, and you can even okay observe or see the slides. Okay, and you can see the screen, so which I have shared. Okay, another example. Okay, third example for inertia of motion, class 9. The rider falls forward when the running horse stops suddenly due to inertia of motion. So during the running, both the horse and rider are in the state of motion. And if the horse stops suddenly, what will happen? The rider who is on the horse does not get the effect of force at the moment. That means that is inertia of motion, and the rider, or let's say person, so who is on the moving horse, obviously, okay, go forward and even sometimes fall from the horse, and again in the forward direction. Another example of inertia of motion you can see there, a running soldier, that is army soldier, okay, Sipahi. A running soldier cannot stop instantly when the commander orders to stop due to inertia of motions. Let's say soldiers, they are in parade, okay, they are doing mass parts, or they are the PT, or they are in their exercise, physical exercise or physical training. And let's say they are in the state of athletes or athletics, that means they are running. And at the moment, if the commander, okay, gives the command to stop immediately, at the time you can see the soldiers cannot stop. So where the commander stops, obviously, and that is because of inertia of motions. So more example you can see there. Okay, if you try to throw a ball, okay, upward, so in a moving train, okay, so you are in a train, the train is in motion, so you are inside the moving train, that means you are also in motion. At the time you have a ball, okay, tennis ball or whatever ball you have, you try to throw that ball upward, and when that ball comes back after some time, and again you will find the ball in your hand. And that is also because of inertia of motion. So before we throw the ball or we do some activity like that, so all we are in motion. And once we throw, and that means the ball is continuously in motions. And even when it goes up, it travels the horizontal directions and it comes back to your own hand because of inertia motions. So class 9, I hope first you understood what is inertia motions and you are clear. So by understanding or by looking some examples of inertia motion, right? Okay, now it's question time. So you can unmute your mic and give answer. So very simple questions. Okay, you can see the picture on your screen. Okay, this I would like to ask you. So looking the picture, so which state or which inertia, okay, the picture is trying to say to you, or which inertia can you define? So in the shown picture.
Inertia motion.
Very good, excellent. Yes, 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 yes. Big clap, please. That is inertia of motion. Good. Yes, already they are in motions and the force is applied to bring that into rest, but what, due to inertia of motion they cannot come immediately okay into the rest. So you can see the upper part of the body lean forward. Good, inertia of motion, very good. And like this I have another picture also. Now please observe this picture carefully and give me my okay that question's answer. The same question is there. So which state or which inertia can you see, so in the given picture? Which
Inertia of rest.
very good, excellent. Yes, this is inertia of rest. Very good. Yes. So before moving the train, okay, the train and the passenger both are at rest. When suddenly, okay, when suddenly a train is moved forward and the passenger or let's say person lean backward. Very good. Inertia of rest. Right. Very good. Next. Okay. Please now observe the third picture, and here also the same question. So you can see a person is riding a bike. okay, that strike on the wall, and you can see a person's okay jumps over out from the bike. So which inertia?
Inertia of
Inertia
motion.
moves. Very good. Yes, inertia motion. Yeah, very good. Thank you so much. Yes. So like this, class 9, you can find many examples in our life. So where we can easily see inertia of rest or inertia of motion. Got it? Okay. Thank you. Now let's okay get connected to another term. So next topic, class 9, that is momentum. Okay, momentum of force. Momentum, momentum, momentum. And in this topic, we will read what is momentum, and we'll also read the mathematical formula for finding the momentum, and we'll try to know the unit of momentum. Okay, so before we go directly to the definition of momentum, let's try to understand okay this concept with some examples. So here you can see. So wait for a while. You can see the picture over there, there is strange. So where you can see two objects of different masses are kept at the same height. Okay, they are kept above the ground. Okay, at a height of 200 meter. So both the objects are placed at the same height, but they are different in their masses. So you can see one object, okay, is of mass 50 kg, so another 5 kg. And here in this condition, okay, there is strange. If I ask you, okay, if I request you to catch, so any one of the object, so when they are dropped, okay, from that height, I repeat, okay, suppose both the objects are dropped. That means now the both the objects they fall, okay, downward. So from that height, and they are in motions. That means they are falling, okay, from the height of 200 meter, and you know they fall with the same increase in velocity. They fall with the same acceleration. So while falling, okay, while coming down, so if I ask you to catch any one of the object, so which object do you choose to catch? And you might give the answer that
5 kg, sir.
obviously, sir.
The
Yes,
dustbin.
which yes,
Get one.
Sir, the 5 kg dustbin.
yes, obviously, yes, you are so clever. Smart people, they always choose 5 kg. Good. And then here, okay, after that, if I want to know the reason that why did you want to choose or why did you want to catch, okay, the object which has less mass, okay, and you may give me the answer, okay, I predict, I guess you may have answer because catching the object of more mass, okay, definitely hurts us. It may okay injure us. That catching 50 kg, that is more mass, it has more mass, and catching such big mass, so we do not have enough energy or we are not able to catch like that. And obviously so much mass can overlap us or can injure us, can hurt us. You may give an answer like this, okay, but in physics there is strange. If you say so, okay, if you say so, because I prefer, I choose to catch 5 kg because it is less mass, okay, it may not hurt us, and 50 kg is more mass, it may hurt me or hurt us. If you say so, if you give the answer like this, in physics your answer may be incorrect or incomplete. Okay, so in general, okay, if you say okay because 50 kg is more mass and 5 kg is less mass, I can easily catch 5 kg, so I choose 5 kg. Yes, you may give the answer like that, but in physics, okay, the answer may be incomplete or incorrect because I want to show another picture, another example, so where we find okay the less effect of mass. Now please, please friends, please observe the next example, or let's say picture that is being shown okay on your screen, which I am sharing my on my slide. So here the ball is flying, and the bullet is also okay that is being fired. That means ball and bullet, both are in motion. And here, dear students, if I again ask you, okay, to choose for catching, so which one do you like to catch, or which one do you dare to catch?
The ball.
Yes, obviously football, because all the students of grade 9, they like to play football. Okay, they are crazy for football, all boys and girls, and we have experience of playing football. And you can see that goalkeeper can easily, catch the ball by different postures. But here, class 9, okay, so you choose to catch ball. Okay, we do not dare to catch bullet, because catching the fight bullet, catching the bullet which is in motion, is almost impossible, or is impossible for us. We say like that. But if you see the mass, if you compare the mass of ball and bullet here, maybe the mass of ball is more than the bullet. Okay, in the previous example, so you do not choose, or you do not choose, that 50 kg mass, because you said that is more mass, so you may hurt us. But here you are choosing the ball, so which may have more mass, you know which may have more mass. And here you can say that, no, because ball may have less velocity, and then the bullet may have more velocity. So here, students, if you say so also, even, okay, the answer will be incomplete. So Sir Isaac Newton, okay, now he explained and he defined the new term, okay, the new relation for a body in motion, for a moving body. So why here you do not choose, or you do not have guts or dare, okay, or you get scared of catching the bullet, fight bullet, okay, and there why you do not dare to catch the 50 kg mass. And he, Sir Isaac Newton, explained that quantity as quantity of motion, that is the effect of force. Okay, so in the first example, in the previous example, the body with more mass has more effect of force, so which may hurt you. And in this example, the bullet, okay, has more effect, that is the more quantity of force, so which may again hurt you or even kill you. So you do not dare to catch the bullet fight bullet. And there, he defined that new quantity as quantity of motion. Now, okay, the physicists or the students, okay, that name that quantity of motion as momentum. Okay, in this picture, the bullet has more momentum than the ball. And in the previous example, the 50 kg mass has more momentum. That means, dear students, okay, the effect of force depends on two factors. That means momentum depends on two factors. So when you include both these factors, then you will have complete answer. Or in terms of physics, you will be correct. Okay, so why I choose 5 kg mass, so why I choose, or why I dare to catch ball. So if you say both the factors, okay, they are mass and velocity. That means that is momentum. So I choose to catch 5 kg mass because that has less momentum, and I choose to catch football because that also has less momentum. And that momentum, okay, depends on mass and velocity. So what is momentum? What is momentum then? Okay, momentum is simply distance. Okay, it's very easy. Momentum is simply defined as the product, multiplication. That is product of the mass and velocity of a moving body. Okay, so when a velocity is constant of different objects, so when the body has more mass, and definitely that can have more momentum. And when, okay, mass is constant, and when that body has more velocity, and the body having more velocity has more momentum, because momentum quantity, okay, directly, okay, depends on mass and velocity. That the relation between mass and momentum directly, okay, proportional. And even the relation between momentum and velocity is directly, that is proportional. So the bullet has more momentum because of more velocity. Okay, and the mass 50 kg has more momentum because of more mass. So when we say that I do not dare to catch 50 kg because of more momentum, then your answer is complete. Okay, there if you say only mass, your answer is incomplete. That means now you have to define, you have to explain the new term as momentum. It has more momentum, so it shows the more effective force. Okay, and we do not catch, or we cannot catch the fight bullet, okay, bullet in motion because of more momentum, because momentum depends on the quantity, okay, like mass and velocity. And so why momentum is defined as the product of mass and velocity. So dear students, next time in the next class, if I ask you to define momentum, what is momentum, and simply you can say, okay, it is the product of mass and velocity. And because of this relation, class 9, the SI of unit of momentum is a kilogram meter per second. The unit of mass is kilogram, unit of velocity is meter per second. That means SI unit of momentum is, okay, kilogram meter per second. And let me tell you students, we always define momentum, okay, only when a body is in motion. Okay, momentum can be measured, momentum can be quantified, momentum can be explained, okay, when the body is moving. So for a moving body, for the body in motions, so we can say, okay, whether the body has more momentum or less momentum, or how much momentum, okay, does that moving body have, like that. So if you are asked to say what is the momentum of a body at rest, then you have to say momentum is zero. Okay, the body which is at stationary, okay, stationary means rest, it always has zero momentum. So momentum can be valued or quantified when the body is moving. So for a moving body, so we explain, or we, okay, define momentum. Okay, numerical problem. So if you are there, okay, still in the class, then you can note down this in a copy too. One numerical problem related to momentum distance. Calculate the momentum of a car of mass 800 kg. So when it is moving with a uniform velocity of 24 meter per second. So the question has clearly given both the factors on which momentum depends. And the factors are mass is given 800 kg, and another factor is velocity, so which is given 24 meter per second. Okay, and momentum is denoted by P. Okay, the symbol for momentum is P, dear students. So we have equation, that means formula for momentum is P is equal to M into B. M stands for mass, B for velocity. Okay, and the question has clearly given mass 800 and the velocity 24. So 800 multiplied 24 is about 19,200 kg meter per second. Okay, so the momentum of the car is also more. So if you get hit, okay, by the moving car, so which has 800 kg mass, and that is moving with the velocity of 24 meter per second, definitely, so you will be collapsed. Okay, there will be a lot of collision, and even, okay, it ruptures you, like that, because you find, okay, numerically the momentum is equal to 19,200 kg meter per second, so which is high momentum, okay, which is more momentum, like that. Let me go to another slide here. Okay, try yourself. So how can we calculate the P of an object? Distance here, P for momentum. And if you know the formula, uh, easily we can find the P or momentum of an object. The formula is P equal M into V. See here, mass of bicycle is 50 kg and velocity of bicycle is 60 meter per second. So I'm giving 1 minute time for you, dear students. Okay, please be active and find the momentum of this bicycle. The bicycle is in motion.
Sir,
Okay.
3,000
3,000
kilogram.
meter per kg meter per second.
Thank you so much. So happy. Thank you so much. Yes, that is 15 to 60. Okay, 3,000 kg meter per second. Good. Thank you. Thank you very much. I'm so happy to hear from you. Yeah. So 3000 kg meter per second. So momentum of bicycle is found to be 3000 kg meter per second. Okay, and if you are hit by this bicycle, so you may slightly get injured, right? But compared to this, if I give another example, now see here, okay, mass of truck m equal 2500 kg, and please here, the velocity of bicycle was also 60 meter per second, okay, and for the truck velocity is the same there, 60 meter per second. Now please calculate the momentum. So where we can use formula, okay, P equal m into v, m for mass, v for velocity, and it will be how much? 2500 into 60. So how much momentum?
1,50,000.
1 lakh? Yes,
1
1.
lakh 50,000 kilogram meter per second. 1 lakh
Thank you so much.
50,000. Sir. Yes, sir.
Yes, yes. Yeah,
1
thank you so much. Thank you, Jendra. Thank you, Subham, for your quick response. Very good. Yes, this is the easy, calculation. Okay. So 1 lakh 50,000 kg meter per second. See, if you compare these two examples, that is the momentum of bicycle and momentum of truck, which is more dangerous for us?
momentum of truck.
Very good. Yes, momentum of truck. So why? Okay, if the people get, okay, that is collided with the heavy vehicles, especially sometime you get, okay, that is, let's say, chance to hear in the news, just like people being killed by, tripper, okay, heavy truck like that. So why? Especially when they get hit by the, tripper or heavy truck, people die because of more momentum of, that truck like that. See here. So momentum of truck is 1,50,000 kg meter per second, and momentum of bicycle was 3000 kg meter per second. If you compare the momentum numerically, you find so much, okay, more, that is the momentum of truck. And obviously, if you get hit, okay, by the truck, and then there will be less chance, okay, of living, that is surviving. Okay. So by this way, so we can find momentum. Did you understand or not, dear students?
Yes, sir.
Okay, so finally, let's conclude today's class. So by having short review about momentum. So what is momentum? Momentum is the product of mass and velocity. Mathematically, momentum equal mass into velocity. So velocity is vector quantity. So momentum is also vector quantity. Okay, mass is scalar and velocity is vector, and momentum depends on vector, that is velocity. So why? Okay, that direction of velocity defines the direction of momentum. So momentum is also vector quantity. And how can we calculate the SI unit of momentum? So mass is kg and velocity is meter per second. So the SI unit of momentum is kg meter per second. Got it? Okay. So one definition for momentum is the product of mass and velocity, where we have P equal m into v. So in another word, we can say the quantity of motion present in the body is also called momentum. So generally, momentum is also known as the quantity of motion present in a body, isn't it? If the quantity of motion is more, that means it has more momentum. If the quantity of motion is less, that means it has less momentum. Right? Okay. Now tomorrow we'll discuss about Newton's laws of motions. For today, this much. Okay. Today, okay, we could finish inertia by discussing inertia of motion with examples, and even we discuss the new topic, momentum. So if you do have any confusion regarding momentum or inertia, you may have queries, for instance. If you do have any questions, okay, if you like to add any point that relevant to momentum, inertia, even the previous topics, okay, like speed and velocity, acceleration, equation of motion. So any confusion, any question? Last time, do you have any questions?
No, sir.
Okay, so no, okay. So for today, thank you very much. So I'm so happy to see you again. So I enjoyed your company. And so before I go, okay, or I leave the class, I request other students also, okay, to come with your video on, because the ultimate goal of education is to, okay, build confidence. I know you very well, and you also know me well. So we know each other. Then why should we hesitate? Okay, to switch on the video. Please have confidence. Feel free, and with the confidence, please come. Let's have interaction. Okay, sometimes you can come with some science facts, so you can share with us. Sometimes you can come with joke, so you can make the class fun and entertain. No man, and sometimes you can come with questions, so you can read the questions. Let's make the class more interactive. So today whole period, so we'll be talking about Newton's laws of motion, and the students of class 9, they have already known, they are familiar with the Newton's laws of motions. Okay, there are three laws of motion. Sir Isaac Newton propounded the three laws of motion. They are Newton's first law, Newton's second law, and Newton's third law. Okay, within seconds, I think we should start. Okay, reading today's class for science. So are we ready, students? Okay, shall we start? Okay, let me begin today's class. So here you can see on your slide over there, the topic for today's discussion is Newton's laws of motion from the second chapter, force. Okay, the whole time, the whole period, we will be just dealing with the laws of motion propounded by Sir Isaac Newton. Okay, the laws are propounded in regard of motion of the body, for the moving body, and this is given by Sir Isaac Newton. So the law is also known as Newton's laws of motion. So everybody please be ready and concentrate. Okay, so what is Newton's laws of motion? So you know, okay, many things are so much about Sir Isaac Newton. So he was from British, British scientist. He was the has given three laws, to describe the motion of bodies, and those laws were mentioned, are published in the book called the Principia Mathematica. So the book where we find, the laws of motions given by Newton is the Principia Mathematica, and there are three laws, for the motion of body, and those laws are Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. So first, second, and third. Okay, and Newton's first law of motion is also called law of inertia. I repeat, Newton's first law of motion is also called law of inertia, and Newton's first law of motion especially defines the force. Okay, force is an external agency which changes or tends to change the position of a body, either from rest to motion or motion to rest. Okay, so Newton's first law of motion defines the force. It tells about the importance of force. So if there was no force, if there was no that application of force, then nothing can be changed from its original state. The body from rest cannot be brought into that is motion, and the body from motion cannot be brought into rest. So the change of position of a body is possible only when the body is acted by the external force. So Newton's first law of motion always tells, it explains about the force, importance of force. Okay, and second law, Newton's second law of motion gives the mathematical expression for calculating the force exerted by a body. So if we do have idea about mass and the acceleration acquired by the body, easily we can find or calculate the force of a body by using the formula or relation F is equal to ma, where F for force, M for mass, and A for acceleration. So this relation, this expression, is given or explained by Newton's second law of motion. And finally, Newton's third law of motion tells about the relation of the force, or it always says that force acts in a pair. So there are two forces, one is action, another is reaction. So when there is action, obviously, there is reaction. So in short, so we try to know about first law, second law, third law. I again repeat, first law gives the definition of force. It tells about the inertia of a body. Second law gives the formula for finding the force. And third law says that the force always acts in a pair. So whenever we apply force on any object, in turn, that object also exerts force on us. Okay, so there are action and reaction during the application of force. Now let's discuss these three laws of motion in detail with example. So first of all, there is strains. You can see on your screen that which I am sharing on my slide. This is the statement of Newton's first law of motion. So if you are there with copy and pen, and just manage time to write this statement, and this is very important. Frequently the state Newton's first law of motion is asked in the exam. You must know. So what is the principle or theory or law given regarding the motion of an object by Newton, which is called Newton's first law of motion. Simply, Newton's first law of motion states that everybody, that everybody that exists in the universe, that means everybody means matter, all the matters, all the objects continues to be, continues to be means it remains in a state of rest or of uniform motion in a straight line. So unless an external force is applied on, if you try to understand this statement in your own way or in your own sense or language, this means that if the body was at rest, the body continuously remains at rest. So it does not change its positions from rest to motion. If it has to change, then there must be the application of force. That means force must be applied on that body, then only the body comes into motion. So why? If the body is at rest, it continues to be in a state of rest. And if earlier the body is in motion, in uniform motion in straight line, the body does not come to rest itself. It continues to be in a uniform motion in a straight line. So to change the body from rest to motion or from motion to rest, there must be an external agent which we call force to be applied on that body. Only then the change in position of body is possible. So it says how important the force is. If there is no force, the body from rest cannot be changed into motion, or the moving body cannot be stopped. That means cannot be brought into rest like that. So for changing the state of body either from rest to motion or motion to rest, there must be that is a external force applied on that body. So this law is called law of inertia. Inertia is the inability of a body due to which it cannot change its position. In another word, it says that the body has property due to which it can remain in its own position. So to change its positions, there must be the application of force, which is further given by Newton's first law of motion. So the statement propounded by the Newton's first law of motion clearly says that the inertia of body and the importance of force. So why this law is also called law of inertia. Let's go to another slide, please. Let's discuss that Newton's first law of motions further in detail. We can explain Newton's first law of motions in different languages. The first sentence you can set there on your screen, there is strings. Please focus and concentrate and try to understand. So what is Newton's first law of motion? Statement, I hope you have understood. Okay, it says that every body continues in its own state unless the force is applied on it. Like that, okay, you can say Newton's first law of motion in another language. Here, a body changes its state of rest or state of uniform motion only when an external force is applied on it. Okay, this is the statement of Newton's first law of motion. So, why students, we always define force, okay, as an external agency, so which is being applied on the body so that it changes or try to change the, okay, position of an object, okay, or state of an object or position of a body or state of a body. Understood? So we can say Newton's first law of motion defines the force. Okay, the change of position is possible, or the change of position, okay, either from rest to motion or motion to rest occurs when there is force applied on the object. So clearly, okay, now we believe we understood that the Newton's first law of motions says the importance or existence, okay, or the definitions of the force. So which is external agency that is to be applied on the body to change the position. So if you go to the second sentence, so you can find there, okay, which says the inertia, and here a body cannot change state of rest or state of uniform motion, and this is the inability. Okay, body cannot change, okay, its position itself, which is, okay, meant to be the inability. The body is not able, okay, the body is unable to change its position itself, and this inability, okay, is called inertia. So why, okay, we can say that Newton's first law of motion is law of inertia. So these two are the answers, okay, for the question. So why Newton's first law of motion is called law of inertia, then how can you, okay, justify that Newton's first law of motion gives the definition of force? The first answer justifies the, okay, Newton's first law of motions that defines the force, and second answer, okay, clearly defines or explains that the Newton's first law of motion is the law of inertia. Okay, I have been repeating the same thing again and again, so I hope people have understood. Okay, so previously, dear students, okay, we discussed many examples, the examples of inertia of rest, okay, and some examples of inertia of motions. Those all examples, either we say, okay, when we shake the branch or tree, okay, and we find that the falling of fruits. So when we beat the carpet and we observe the dust particles, that flew away from the carpet, or when, okay, the bus is suddenly, okay, that is, let's say, moved or started from rest, and we find the passengers lean backward, right? And that, and we find that when the bullet is fired even on the glass window pane, and we find that the bullets makes a hole without cracking the glass, and we say that when the bus is, especially moving bus, is stopped, then when the driver applies the brakes and we find the passengers, they lean forward, or when the driver of a bus turns, bus to the left side, okay, in the rush, then we find the passengers, they lean right to the right side. So these all are the examples of Newton's first law of motion. Though earlier, okay, we have mentioned them as inertia of, rest or inertia of motions, looking the conditions of the, objects, just like, so when we try to pull the paper, okay, that is kept on over the glass which has coin on it, then we find after pulling the paper quickly or immediately, we see that the coin falls in the glass. That means coin does not come with the paper, and we say that that is due to inertia of rest. Okay, we apply the force on the paper, so the paper comes into motion, but the coin does not get the, okay, force, so that remains at rest, and due to which it falls on the glass. That example is also the example of Newton's first law of motion. So either you say inertia, a law of inertia, or you say that is Newton's first law. All those examples are Newton's, okay, first law of motions examples. Okay. Then in another language, you can see here on the screen, okay, the statement of Newton's first law of motion, that an object in motions will remain in motion unless acted upon by an outside force, that is external force. An object at rest will remain at rest unless acted upon by an outside force. Okay, the language is different, but the principle, the law, and the meaning is same. Okay. You can see there. So before, okay, we throw or we hit the baseball, the baseball is at rest. And if we do not apply our force to hit the baseball or to throw the baseball does not come itself into motion. Okay, so the baseball can be moved, it can be brought into motions when we apply the force. And once when the baseball comes into motions by applying the force on that, so it doesn't come into rest. Okay, and for that we have to apply our force for catching that. And then when the catcher or the fielder catch the flying ball, that means for during that time we have applied force. We are applying the force to bring that ball into rest. So either from rest to motion or from motion to rest, if we have to change the position of body, okay, in every that is cases we have to apply the force. You can see the last picture over there. So okay, similar picture yesterday also we discussed, we saw, and that tells about the inertia of motion. Okay, and that is definitely that is Newton's okay first law. Newton's first law. Okay, let me go to another law, students. Okay, I hope so. You are still in the class there, and you are listening to me properly, and you can see. So the words, okay, the written about Newton's second law of motions on your screen. So if you get any problem, if the words are, if the pictures are not clear, okay, then you can tell me. Okay, and then I'll try to make it more clear so that you'll understand. This is your class time. So you came to join the class means that whatever you are taught, so you have to understand all the topics and all the terms like that. Now Newton's second law of motion, okay, gives the formula equations for finding the force. And formula for finding the force, students, that is F is equal to ma. Okay, that means the force applied, okay, on a body to change its positions depends on two factors. The force exerted by a body, okay, depends on two, that is factors. One is mass, okay, another is acceleration. And this law, Newton's second law of motions, okay, gives the equation formula and tells the relation, okay, about the quantities, okay, like force and mass and force and acceleration's relation. So what is the relation between mass of a body and the force it exerts? Okay, and what is the relation between acceleration, okay, of a body and the force it exerts? Okay, the relations between these, okay, factors, or let's say relation among the quantity like force, mass, and acceleration is clearly, okay, given by Newton's second law of motion, and it states that acceleration produced on a body is directly, now see there the relation between the force and acceleration. Okay, the relation between force, okay, applied and acceleration is directly proportional. Then what's about the relation between that acceleration and mass? And the relation between mass and acceleration is inversely proportional. So please go on writing. Please write down this statement. Okay, in your copy, dear students, the statement says that acceleration produced on a body is directly proportional to the force applied, okay, on it, and inversely proportional to its mass. So the statement here, okay, is trying to say to us that is the relation between acceleration A, okay, and force F, and the relation between acceleration A and mass M. Okay, and the relation between acceleration and force is directly means, so as we apply the magnitude of force, okay, for moving the body, then you can see there the acceleration of a body also increases. So if you paddle, okay, the bicycle faster, or let's say more, That means you are increasing the magnitude of force. You are increasing the quantity of force to move a bicycle, and you can see there your bicycle, okay, moves faster. It moves faster means that the acceleration of the bicycle increases, right? Whereas also, if we compare the two bodies of different masses, and if you apply the same amount of force on two objects with different masses, then you find that the mass with small object accelerates more, okay, but the mass which is more on that object accelerates. It's like, okay, if you apply the same amount of force, you can easily throw, okay, a small stone, a small piece of stone, but applying the same force, then I think you cannot even move a big stone like that. Okay, so the acceleration is inversely proportional to the mass. If mass is more, so acceleration becomes less, and if mass is less, okay, acceleration becomes more. And I hope you have finished writing in your copy. Again, meanwhile, you are also listening to me. This is okay. Now this is very important part, and this derivation, okay, this proof of the formula F equal ma is frequently, okay, asked questions in exam. So in every exam, so in most of the test, okay, this question is asked, and the question is asked as a proof F equal ma, where the symbols have their usual meanings. So this is given by Newton's second law motions. So dear students, I'd like to request you all, okay, to write, so okay, this in a copy, and let's begin. So start right place. F equal ma, where the symbols have their usual meanings, means F means force applied, small m for mass of a body, and a, small a for acceleration of a body. So for deriving this relation, okay, for proving this expression, you have to start with the language, considering m as mass, capital F as force, and small a is acceleration. So you can see, okay, on the screen and write in the copy. Let us consider a body of mass m, right, is moved by a force F, and if A is the acceleration produced on the body, then according to Newton's second law of motion. So here, so we have given the meaning of symbols: m for mass of body, F for force applied, and A, okay, for acceleration produced, so by the applied force. Ready? So after considering these symbols, okay, in the language or in the sentences, now let's go to the statement of Newton's second law of motion. And according to Newton's second law of motion, okay, the first sentence, there is okay, the relation between acceleration force. You can see oscillation A, okay, small a, produced on a body is directly proportional to the force applied. Okay, this is the language, so which describe the relation between acceleration A and force F. Okay, and it clearly says to us that the relation between them is directly proportional, and which is symbolically written as, that is A proportional to F, and that is equation 1. Okay, equation 1. So from the first part of the Newton's second law of motion, so which is saying the relation between acceleration produced and force applied, that is A directly proportional to F, capital F. Okay, that is equation 1. And the another part of the Newton's second law of motion is that, okay, the relation between acceleration produced and mass of the body. And in language, you can find there the oscillation A produced on the body is inversely, okay, inversely opposite, okay, inversely proportional to the mass of the body. So inversely proportional to the mass of the body. That means when one factor is increased, another decreases. So that is just opposite, okay, with each other. So that is similarly A, so proportional to 1 upon m. Okay, 1 upon m, 1 by m. That means inversely proportional. So A is inversely proportional to mass, and that is equation second. So equation first, there was A directly proportional to force, and from equation second we have, okay, A inversely proportional to the mass. And combining, okay, please go according to the steps. After having equation first and second, so we are going to combine both the equation. So combining equation first and second, because in first also at left side we find A, and in second also at left side we find A. Okay, and that the A that in first and second is same. So the oscillations in first equation and oscillation in second equation is same. Okay, so we can write A only and proportional to F upon M. So from equation 1 and 2, okay, finally we get F proportional F upon M. Now rearranging, so rearranging the equations, here we have, that means F proportional to MA. So M, okay, that cross multiply with A. So if you take the M to the left hand side, then there will be MA, okay, and by changing the side, that means you bring the F to the left side, and then MA, okay, that keeping the right side. So there, this one, okay, F proportional to MA. And 2, okay, convert that into equations. So we have 2, okay, convert that proportionality, okay, proportionality into the, okay, equation. For that we need a constant, okay, and so next step we have F is equal to K. So here K is the constant of proportionality, okay, that change into equation. So if F equal K MA, that means equation 3 we get. Okay, we got equation 3. And if we consider, suppose the applied force is 1 Newton, okay, and how much force is applied? 1 Newton on what body? For example, the mass is 1 kg, okay, mass is 1 kg, and then, okay, and by applying 1 Newton force on mass 1 kg, the oscillations will definitely produce equal to 1 meter per second square. So if you consider such, okay, keeping all units, force also 1, okay, Newton, mass also 1 kg, then oscillation will obviously becomes, okay, 1 meter per second square. Then you will get the value of K, okay, it will become 1, okay, you will get the value of K equal to 1. And if you put the value of K in equation 3, so okay, which was F equal KMA, that considering F equal 1 Newton, mass equal 1 kg, A equal 1 meter per second square, so you get K equal 1, and putting the value of K equal 1 in equation 3, at last you will get F equal MA. So finally, so we get, okay, or we got the relation, okay, F is equal to MA, and this is the formula. So we need to know, okay, for finding the force, please remember this, okay, F equal MA. And next, in next class, by using this formula, so we'll practice, okay, some numerical problems. So in next class I'll come with, okay, numerical problems from equation of motions and from Newton's second law of motion.
Excuse me, sir.
Please.
Sir, how
Yes,
that
Shivam.
K came in equation 1? Equation 3?
Yeah. In equation 3, okay, in equation 3, to remove the proportionality we have used constant, yes, and K the constant there. And just if you put the value of F, M, A, and then finally we get K is also 1. Okay, this is consideration. This is the suppose, okay, and this is let's say assumption. So assuming force equal 1, mass equal 1, then A equal 1, then if you get K equal 1, then finally you can keep the value of K as 1, then you get F equal MA like that. That means there the value of K is kept as 1 constant. 1 is constant like that. Got it?
Sir, then why that proportional sign is removed?
No, it has to be removed for changing that into equation. Changing that into equations, that into the expressions like that, so that you will get the formula or you will get the relations, okay, at last between the factors or quantities like that. So there are many expressions, so where we get constants, okay, for changing the proportionality or proportional into the equation. Got it?
Yes, sir.
Okay, yes please. Okay, allow, okay, Finally, please see here. Okay, look at the screen. You can see this is the sum up of Newton's second law of motion. So from Newton's second law, we got F equals ma. Okay, that the unit of mass is kg and unit of oscillation is meter per second square. So kg into meter per second square means Newton. So Newton is the SI unit of force, and dyne is the CGS unit of force. Okay, and if you have, let's say, different objects with different mass. So if you have a heavy truck, right? Another object is a small car. There are two objects, one a heavy truck, another a small car. And obviously, to move a heavy truck, okay, you need more force. Okay, you need more force. Means, so truck has more mass, right? More mass, and to oscillate it, okay, it needs more force. Means, what is the relation there is that the oscillation is inversely proportional to the mass. So if we keep the magnitude of force constant, that means if you are applying the same amount of force for both objects, okay, for moving truck also, for moving car also, if you apply same amount of force, and that amount of force may, okay, be enough to move the car, but that force, okay, may not be enough for moving the truck. That means that amount of force, okay, is able to produce oscillation on a car, but that may not be able to produce oscillation in the truck because truck has more mass. So to move a big object, we need to apply more force. Okay, so to accelerate it means that is the oscillation is inversely, indirectly proportional to the mass here, right? Now, if you have there, see there, the next picture there, the same force was applied to the heavy truck and a small car. Obviously, okay, I already told that the car would oscillate faster than the truck. But if the forces, okay, applied were different, okay, that may produce same oscillation. Now, in another case, if you take the same masses, okay, of objects, for the third time, let's take the two objects, okay, as both cars. That means that have same masses, and if you apply different forces, okay, on both cars, so which have same masses, and you can easily find that, okay, the car, okay, which gets more force applied on it, that will oscillate more. The car which experiences less force, okay, will oscillate less. So if the masses are constant, that means increasing the force, so acceleration increases. Okay, so more force, more acceleration, and less force, so less acceleration. Means the relation between acceleration and force is directly proportional. Got it? Okay. Thank you so much. For today, this much. In today's class, we discuss, okay, for long about Newton's first law and Newton's second law. Let me request you all the students, okay, first of all, you must be familiar with the statement. So what does Newton's first law of motion state? Okay, and what does Newton's second law of motion state? And secondly, so we have to, okay, get the concept with examples. So what are the examples you can give for justifying the Newton's first law motion? And what are the examples you can give for justifying the Newton's second law motion? And after that, so you have to understand, okay, especially on what that Newton's first law of motion focuses. So Newton's first law of motion focuses on the definition of force and inertia, whereas Newton's second law of motion emphasizes, okay, the relation, okay, among the force, mass, and acceleration. So from which we get the relation F is equal to ma, right? So these are the important parts. So class 9, lastly, so I would like to, okay, ask you if you do have any queries or let's say questions for Newton's first law, then you have just your time, please. Okay, yeah, today I saw, okay, Vishranti, Pragya, oh, good to see you. And Srijana, can you hear me? Last night, do you have any questions, okay, from Newton's first law, second law? Next time, I'll come with numerical problems and with examples of Newton's second law of motion. Got it? Okay. For today, this much. Thank you so much, class 9. Have a good time and be ready for another class. Thank you. Bye bye.
Bye, sir.
Bye, sir.
Bye bye. Yes, please
Sir.
enjoy your time. Thank you so much. Okay, next time please come with questions. Okay, I'll come with numerical problems and examples of Newton's second law. And I hope that in next class we will complete this lesson second, because only one topic is left, that is Newton's third law of motion. Then we will, okay, conclude the lessons. Thank you. Bye bye.